Okay, welcome back. This is Mr. Hassan's Maths channel. I'm now going to answer question number 2 from the June 2014 International A-Level Edexcel Mechanics M1 paper. And this question is about vertical motion under gravity. And this question here, I'm actually going through this question as a kind of like a clarification of one of the comments and one of the questions asked to me on the channel by one of the students asking me about how, inquiring about how I take my, direction, positive or negative, what's my method of doing so when I'm dealing with this vertical motion under gravity. So I want to just address this and clarify that issue for that student, for others who might have the same question. Now, one of the things that I always like to do in mechanics is to take the direction in which something was initially moving as the positive direction. It just makes everything clearer for me, right? So that's how I normally go about my work here. I normally take the direction which is in which something initially starts moving as positive. Okay, that's how I deal with it, right? So let's look at this question as example A and B. You'll see slight differences in them, and hopefully that will clarify this issue to you. So it says a ball is thrown vertically upwards with a speed 20 meters per second from a point A, which is h meters above the ground. The ball moves freely under gravity until it hits the ground 5 seconds later. So we have a situation here where there is a ball which is thrown from a point which is above the ground. So let's say this is the point A above the ground. It's a certain distance above the ground, h, we don't know what that is, and here's the ground. So this is the point, the level of A, and this is the level of the ground, which I'll call B, right? This is the ground. I'm just calling it B for the purposes of the question. So the ball is projected from A upwards. Okay, it's thrown vertically upwards. So it's thrown vertically upwards. Okay, so let me just show that here. So let's say it's thrown upwards vertically, and then it drops down until it hits the ground 5 seconds later. So of course, when it's thrown vertically upwards, it will reach a maximum height which the velocity becomes 0, then it will fall down until it hits the ground. Okay, so now this is the starting point. This is like the origin, the starting point. This is when time equals 0 when it's thrown at this point here. Okay, it's going to go past this point again on its way down, but it reaches the ground when time equals 5 seconds. All right, the distance that it is above the ground at the point where it's projected, okay, so that distance there, I'm going to call it, they've called it H here. I'm going to call it X for now. I'm going to call it X for now, and you'll understand why at the end. I'll call this X. We know that it's projected with a speed of 20 meters per second. So at this point, it's projected with a speed of 20 meters per second. I wrote per second squared. Okay, per second. And we know that the force of gravity always acts towards the ground. So this is going to be G acting downwards. All right. Now, as this object has been projected upwards, I'm going to define my upwards direction as the positive direction in this question. So I've written that to show. All right. So now I'm going to write down the values of displacement, initial velocity, final velocity, acceleration, and time, SUVAT. Now S, okay, X is going to be the displacement from A. Okay, I know my value of X is going to be negative because I know that X is below the point that we have taken as our origin. And as we're taking up as positive and this is below that point, I know it's going to come out as negative. So the X will be a negative value for sure, because the displacement, remember, is not the total distance that it's traveled. The S doesn't mean the distance has gone up and then down. The displacement is how far away it is from its initial position. Okay, so it's this distance below its initial position we're taking up as positive, so that's definitely going to be a negative value. If it's not, then there's something wrong in my calculation. I know that for sure. All right, now U is going to be positive 20 meters per second because we've taken up as positive. Now V, we don't know what it is. This is going to be the final velocity just at the instant before it hits the ground. Okay, we don't know what that is. The acceleration is G but acting downwards, so it's negative 9.8 meters per second squared. Remember, we must take G as 9.8 in M1, and as it's acting down and we're taking up as positive in this particular part of the question, we know that A is negative 9.8, and as we're told, T is 5 seconds. So in this question, what we have to deal with here, what we have to deal with here in this particular question is we've got to find S, we know what U is, we don't know what V is, we know what A is, we know what T is. So we've got to deal with S, U, A, and T. And we should know our Suvat equations. S equals U times T plus a half AT squared. That's going to give us our answer. So S is X here. U is the initial velocity, which is 20. T is the time it took, which is 5, plus a half times A, which is negative 9.8, times 5 squared. And that will give us the value of X. So let's put that in the calculator. We have 20 times 5 plus a half, can use 0.5, put it properly, times negative 9.8 times 5 squared. Now that gives us negative 45 over 2. So we can say that X equals negative 22.5 meters. So that is the displacement of the point where it hits the ground from A. So H tells us H is the point A is H meters above the ground. So we can say therefore the value of H is 22.5 meters. We don't need the negative sign. It's just asking us to find, okay, the value of H. It's 22.5 meters above the ground. Okay, so we don't put the negative 22.5. That's the displacement of X from A, but it's asking us how far is A above the ground. It's 22.5 meters above the ground. Okay, so that's why I didn't call this H in the beginning. I called it X, and then H is basically that same, just distance, not the displacement. Okay, we've taken up as positive, and this point is 22.5 meters below. Okay, so that's how we can deal with that question. That's part A. Now we're going to move on to part B. Now for part B, it says a second ball is thrown vertically downwards with a speed W meters per second from A. Okay, so there's a second ball, and moves freely under gravity until it hits the ground. The first ball hits the ground with the speed V meters per second, and the second ball hits the ground with the speed 3/4 V meters per second. Find the value of W. Okay, so now we've got a situation where there's another ball thrown from this from A, but it's thrown vertically downwards, and it hits the ground with a speed W. All right, and it's freely under gravity. It's moving. So therefore, we need to find the speed with which it was thrown. Now we know the displacement now. It's 22.5. Okay, and we also know well, we know what G is, the acceleration, which is G. Okay, and we also can work out from what they've told us here what its final speed, the speed with which it hits the ground is. Okay, it says the first ball hits the ground with the speed V meters per second, and the second with 3/4 V meters per second. Now we can work out the speed with which the first ball hits the ground from the information given here. Okay, we have to find V, we know U, we know A, and we know T. So we can first of all find out this. We can find the value of V. Find what V is. Okay, and we know that you can use V equals U plus AT. Now V is U, which was 25. Okay, we're still using the upwards as positive because we're dealing with the first ball. This is the first ball. Okay, so it was projected upwards, so we're taking up as positive for this part of the question. So we got V equals, V is what we have to find, U is 25, A is negative 9.8, and T is 5 seconds. And T is 5 seconds. V equals U plus A times T. Okay, so we can work out what V is. So V is going to be, we got 25 plus 5 times negative 9.8, which is negative 24 meters per second. Why do I keep putting squared? Per second. Okay, so as we know, that means it's moving downwards according to our first situation. Okay, it's moving downwards, so we've got V equals negative. Okay, in this particular situation, negative 25 meters per second. Now, the second ball is thrown vertically downwards. So now I'm going to be dealing with the second ball. So the second situation now is finding W. So we got to deal with the second ball. Now this is a new situation which I'll draw separately just to make it clear. In this situation here, we still have the same situation that you have a point A. Now we know the thing, what we know about point A, we know that the distance between A and the ground, not the displacement, but the distance between A and the ground. Where is the arrow's gone? Sorry. Okay, the distance between A and the ground, okay, which we've called B, A and B. The distance between them is 22.5 meters. We also know that the ball was projected downwards with a speed of W, and when it reaches the ground, just before it hits the ground, its speed is 24 meters per second. Okay, that's the speed, not with that's not the speed like some people say, oh, it hits the ground, its speed is 0. No, if the ground wasn't there, its speed wouldn't be 0. All right, so it's talking about the speed at the instant just before it hits the ground. That's the speed it would be traveling at. Okay, the ground got in the way, of course, it's going to hit the ground and it's going to maybe bounce, whatever, but it's going to come to a stop. But we're not talking about that. We're talking about the instant before it hits the ground. That's what we're talking about when we're talking about its final speed there. Okay, so that's another misconception some people have. So now, in this situation, we also got of course, the force of gravity, which always acts down. Now, in this situation, as this ball in the second situation is projected downwards, what I'm going to do in this situation, I'm going to take down as positive. Okay, so in this particular situation, I'm taking down as positive. All right, so now I have S, U, V, A, and T. So S is now 22.5. It's going to be a positive value because I'm taking down as positive. And U is W, which we have to find. And V is its final speed, which is 24 meters per second. Now I'm going to take that as positive again. Why? Because it's going down. I'm taking down as positive. A is 9.8 meters per second squared. Now I'm going to take this as positive again. Why? Because it's acting down and we're taking down as positive in this part of the question. And the time we don't know, and we have to find U. So we got to do with S and U and V and A. So we can use V squared equals U squared plus 2AS. So we know V is 24, so that's 24 squared equals U squared, which I'm going to call W, so W squared plus 2 times A, which is 9.8, times S, which is 22.5. Okay, so that will give us what W is if we simplify it. So we got 24 squared, which is 576, minus, and you got all of this, I'll just work out what that is. That's 2 times 9.8 times 22.5. So it's minus 441 equals W squared. So you got 576 minus that last answer, that gives you 135. So W squared equals 135. So therefore, 24 squared. Yep. So 135, and you got to find the square root of the answer, which gives you 3 root 15, which is 11.6 meters per second. So W is equal to 11.6. What was it? 11.6185. So W is equal to 11.6 meters per second. That's the speed with which it was projected when it was thrown down. Okay, so W equals 11.6 meters per second to 3 SF. We could answer in 2 SF. I could call it 12 meters per second. That's perfectly fine as well. Okay, both are acceptable because we've used G as 9.8. So both of these are acceptable answers. It's absolutely fine if you write either of them. Okay, so that's how we answer such a question. Welcome back. This is Mr. Hassan's Maths channel, and I am now going to be going through question number 2 from the June 2014 International A-Level Edexcel Mechanics M1 paper. And I'm going through this question because a student has asked me on the comments in my channel about a particular issue about how I take which direction as positive or negative when I'm dealing with vertical motion under gravity. So I'm going to clarify that using this question, which I found is suitable for doing so. Okay, so first of all, let's just get started. Now, in general, I always like in mechanics to have a very clear idea of what direction I take as positive or negative. And for me, I mean, there's different methods you could use and different ways that you can use whatever you're used to and whatever you prefer doing as you wish. But what I like to do myself personally is I like to keep a clear idea of the direction in which something was initially projected in or started moving in or had the tendency to move in, when we're dealing with statics, for example, is the direction I like to take as positive. So the direction in which something initially moves or initially is trying to move is going to be the direction that I like to take as positive. So in the same question, I might have upwards positive in one part of the question and downwards positive in another part of the question, depending on the situation. Okay, you know, like different parts of the same question, for example. So that this question will illustrate that hopefully for you, in part A and part B. So it says a ball is thrown vertically upwards with a speed of 20 meters per second from a point A, which is h meters above the ground. The ball moves freely under gravity until it hits the ground 5 seconds later. So you've got a situation where there's a point A, which is somewhere above the ground. So say this is the ground over here. You have a point A, which is above the ground somewhere. Okay, let me make that straight. Okay, it's above the ground. Like, say, a little platform here above the ground. That's where the point A is. Okay, that's the point A. Now, the object is thrown, and the point A is a certain distance above the ground. Okay, now I'm going to, for the purposes of this question, I'm going to, let's just call this distance X for now. Okay, we've called it H here, but I'm going to explain why I called it X as I go through the question. Now, that ball is projected vertically upwards. It's moving freely under gravity. So it's going to come to a stage where it comes to instantaneous rest, and then it falls back down to the ground, and it hits the ground, okay, 5 seconds later. So I'm going to call the point B the level of the ground. That's going to be 5 seconds after it was thrown. And the point A, when it was thrown, the initial speed with which it's thrown in is 20 meters per second upwards. Okay, now, what else do we know about the situation? Well, we know that there's a force of gravity acting in the downwards direction, okay, which is G, 9.8 meters per second squared. Now, let's put our values for the Suvat equations. Here we have constant acceleration, okay, which is gravity. So we can use the Suvat equations. So let's put our values that we have for Suvat. Now I know I'm going to call this displacement X. Now X, I know my answer to come out as negative because I've taken A as my starting point, and I know that X is below A because it tells us it's going to go hit the ground and A is above the ground. So if I take before I say that, let's just clarify one thing. Now, as this object was thrown upwards, I'm going to, in this question, take the upwards direction as positive because its initial motion was upwards. It's thrust upwards. So therefore, up is going to be positive and down is going to be negative, right? So I know X is going to end up as a negative value in my equation here because I know X is below A. right? So it definitely will end up as negative if I take up as positive. The initial velocity is up, and I've taken up as positive, so my initial velocity u is 20 meters per second, a positive value. V, I know it's a negative value. I don't know what it is. I could calculate it eventually, but we don't have to find it in part A. So V, I'll just call it V. A is the acceleration due to gravity, which is acting down, and we have taken up as positive. And the acceleration due to gravity, therefore, is going to be negative because I've taken up as positive and it acts towards the ground. So it's negative 9.8 meters per second squared. And as we see, time equals 5 seconds. Okay, of course, time is a scalar quantity. Right, so now, what we're going to do here is we're going to think about what we need to do to work out the value of this S, which is X here. So we have to deal with this. We have to deal with U. We don't have V. That's going to help us. We have A and we have T. So these four letters in our equations of motion, Suvat equations, S equals, you got U and T and A and S, UT plus a half AT squared. For my equations of motion, which we should memorize and know, this is the equation that's going to help us to answer this particular question. So now, we know what, we got to find what the S is, we call it X here. U is 20, T is 5, plus a half times A, which is negative 9.8 times, and you got 5 squared. And that's going to tell us the value of X. So we have 20 times 5, which is 100. Plus, and we're going to have a half, 0.5 times negative 9.8 times 5 squared. And that will give us negative 45 over 2. Negative 45 over 2. So we can say X equals negative 22.5 meters. So that is the displacement of B, which is on the ground, from A, because we're dealing with the journey when it starts from A and it ends up at B. That's what we're dealing with. It starts at A, ends up at B. And, you know, the X is displacement of B, okay, from A. And we can see that B is below A because our displacement ends up as negative, right? So after 5 seconds, it's gone below A, 22.5 meters below A. That means H is defined as, okay, A, the distance of A above the ground. So therefore we can say H is equal to 22.5 meters. Okay, because it's the distance of A above the ground, okay, which is that distance. The displacement of B from A is negative 22.5 as we've taken up as positive, right, because that's the initial motion. All right, so there's how you can do with part A. Now for part B. It says a second ball is thrown vertically downwards with speed W meters per second from A and moves freely under gravity until it hits the ground. The first ball hits the ground with speed V meters per second, and the second ball hits the ground with speed 3/4 of V meters per second. Okay, so find the value of W. All right, so we need to find the value of the speed with which the first ball is thrust downwards. Okay, it's thrown vertically downwards. All right, now, in order for, let's just draw the situation here. We have a similar situation. The point A above the ground. We have point B, which is on the ground. So this is the point A. On the level of A, this is the level of B. Now, in this case, the ball is thrust vertically downwards with a speed of W, and it hits the ground with a speed of 3/4 of V, which is V being the speed with which A hits the ground. Okay, so we know that the distance between these 2 points is 22.5. Okay, this is 22.5 meters. That's how far that distance is. And we know that the gravity is acting downwards. Now, in this case, what I need to know before I can start is what the value of V is. Because if I know what the value of V is, I know what the value of this speed with which this hits the ground, the final velocity of the second ball when it hits, just before it hits the ground, right? Which is what I need to know, because then I can find what W is, because I have S, I have A, okay, and I'll have V, right? And therefore I will be able to find the value of this initial velocity. Okay, so let's first of all find what V is. So the first step is to find V. We have to find V, which is the final velocity of the first ball. Okay, so we have to find the final velocity of the first ball. So we're going to use the same values here. We're going to use this situation here. Okay, so we're gonna have S as negative 22.5 because I'm taking up as positive for the first situation. The first ball is projected upwards, so up is positive. So S is, we know what that is, negative 22.5 meters. That's the displacement. The initial velocity was upwards 20 meters per second. The final velocity was downwards, which was, well, we have to find. Okay, we have to find what that is. That's what we're looking for, capital V. Acceleration is negative 9.8 meters per second. Because remember, I'm dealing with the first ball here. And the time was 5 seconds. That's how long it took for it to hit the ground. So with this, I can use the equation V equals U plus A times T. I have to deal with V, U, A, and T. That's probably the easiest one we're going to use. So our final velocity of the ball A is V. That's equal to U, which is 20, plus A, which is negative 9.8, times T, which is 5 seconds. So our final velocity, therefore, is going to be equal to 20 plus negative 9.8 times 5. Whoops. Okay, and that gives us negative 29. 20, V equals U plus 80. Was it 20? Yeah. V equals U plus 80. That's right. Okay, so it's negative 29 meters per second. So that's the speed with which V hits the ground. Okay, negative 29 meters per second. Why negative? Because we know that it's going downwards. Okay, so now what we need to do now is look at situation 2, which is the second ball, okay, which is this situation here. So let me take this and just bring it down here. Doesn't want to come down. Come on, that's better. Okay, so now we're dealing with the second situation. All right, so I know that this value here is 3/4 of 29. Okay, I'm just putting its value in times 0.75, which gives you negative, well, I'll keep it as positive 27.5 meters per second. That's the speed with which this ball hits the ground. Okay, just before it hits the ground. That's the speed it's traveling at. Now, in this situation, I have my suvat again. Now, this ball was projected downwards. It was projected downwards. Its initial motion is down. So I'm going to take down as positive in this question. Okay, because the second ball is projected down. It's thrown downwards. So that means downwards is positive and upwards is negative. Now, in this case, S is the displacement, which is 22.5 meters above the starting point. So it's, below the starting point. So it's going down 22.5 meters, which is our positive direction. So this is going to be a positive 22.5 meters. Our initial velocity is W, which we have to find. Our final velocity is going downwards, 21.75 meters per second. It's going down, so it's positive. The acceleration due to gravity is also down, which in this situation is also positive 9.8 meters per second squared. And the time I don't know. So if I look at these, I want to find what W is. I've got to do with S, U, V, and A. it seems I'm going to use v squared equals u squared plus 2as. So I know what v is. So I've got 21.75 squared equals u, which w, so that's w squared, plus 2 times 9.8 times 22.5. Okay, so now that will give us hopefully our answer. So I've got my 21.75. I've got to square that. Okay. All right, I'll just do this in one go. Minus, I'll just subtract that. 2 times 9.8 times 22.5. And that gives us 513 over 16. So w is equal to 513 over 16. That's w squared, sorry. So w is the square root of that, because that's w squared. So the square root of the answer there gives us 5.6623. 5.662, 5.662, dot, dot, dot. So w therefore is 5.66 meters per second. That's the value of w with which it was thrown down. And there's the answer to part B of this question. Okay, so notice that in part A, I took it up as positive. And therefore, my initial velocity was positive. My acceleration was negative. Okay, in the second part of the question, okay, after I found what the value of the velocity was as it was hitting the ground, just before it was hitting the ground, the first ball, I took 3/4 of that value, and that's the magnitude of this, like the speed with which it hits the ground. Now I've got to think about in terms of velocity. In the second question, second part of the question, the ball was projected down. Therefore, I'm taking down as positive. Therefore, the displacement is 22.5, positive. The final velocity is 21.75, positive, because it's going down at the point where it hits the ground. And the acceleration due to gravity is also positive because it's down. Now, it's no problem if I take up as positive always. There's no problem in these questions. If you want to do that, that's perfectly fine. I personally would find to take the direction in which something was initially thrown makes it a bit easier for me. Okay, but if you want to take up as positive the whole time, it's absolutely fine. And in that case, but then you have to be careful. Your displacement here would be negative 22.5. Your final velocity would be negative 21.75, and your acceleration would be negative 9.8, and you'll end up with the same answer. You'll end up with exactly the same answer. Okay, so it really doesn't matter. It's just that I prefer to take the initial direction which something was thrown at as positive. Okay, and the reason I do that is not only for this topic, but especially for topics like dynamics, when you have something being pulled up a slope, or falling down a slope, or released and sliding down a slope, things like that. I find it much more kind of logical and easier for me to lay out my work and to understand by taking the initial direction that something was projected in, or moves in, or is trying to move in the questions which involve friction. Something might be like sliding down or wanting to slide down, or whatever. That direction as the positive direction. Okay, so as you see in the same question, part A I took up as positive, and part B I took down as positive. Okay, anything to do with that second ball that was projected downwards, I took down as positive. Anything to do with the first ball, I took up as positive. All right, so I hope that was clear and clarified that point for especially the student that was asking me about this. Thank you for watching. Other questions that you might want to see from this particular paper when I get around to answering them will be in this playlist that will appear over here. Generally, the older papers, I don't really answer those questions. I tend to do the newer questions. So if you have a question from one of these older papers, then please do leave a comment, ask me. I'll try my best to answer it when I get time. So questions from this paper, when I answer them, will be in the playlist that will appear in this region over here. All the questions I've answered about this particular topic, which is to do with kinematics, will be in the playlist that will appear over here. I'm thinking of making a new playlist just with questions to do with vertical motion under gravity, a separate one. I'll probably make a playlist and put that over here as well, just to separate this from other parts of the same topic. And you can subscribe to my channel by clicking on the link over here. Thank you for watching, and see you soon.